started.
Oh, sorry, Amanda, did you have something else to say?
Oh, no, I can hand it right over to you if you want, Ken. I was just going to say hello to everyone. And the only thing I want to mention real fast, for my Biology 2870 class, please check your Canvas announcements for a quick announcement, but I don't want to take any class time from these two excellent speakers. So I will hand it actually straight over to Kent to introduce our first speaker.
Okay. It's really a great pleasure to welcome Heng back here to talk to what is now the School of Biological Sciences, but was just the biology department back in the day. Heng got her PhD in my lab, and then she hung around and did a postdoc, and she had her hand in a lot of different projects while she was here. It was all Drosophila genetics. In the beginning, she played a big part in the development of gene targeting technology that we were working on back then. And she developed a very clever method to make deletions of target genes in Drosophila, as well as contributing some other to other projects. And then as a postdoc, she went on to work on, believe it or not, heart disease. So again, in Drosophila, she was modeling a cardiomyopathy that was a result of a mutation in humans in a small heat shock protein. And she showed by extensive genetic analysis that the cellular defect was a result of an excess of reducing equivalents in the cell. So it was a result of not oxidative stress, but reductive stress. So that was really an unusual and interesting finding. And that was near the end of her time in the lab. I think Heng left the lab around 10 years ago. I don't remember exactly what the date was. And since then, her work has taken her on a pretty different path. I'm pretty sure that I know what she does now, but I'm not going to say because I could be wrong, and it would be better if I just let Heng tell you herself. So I'll let Heng take it away.
That's so nice, Kent. I appreciate it very much. So like Kent said, I left Drosophila genetics like a long time ago. And I've been wondering what I was about to do with my life for quite a while. And it's kind of interesting because when I was still sticking around at the U, I went to a panel speech with a bunch of like industrial people, including BioFire's founder and lots of other people. I learned a lot from there, but I was still kind of a bit scared of that entire thing. And now look where I am. So that's one of the reasons I want to come back and talk about this. Interesting, I can't advance it. Oh, good. So brief outline, I hope I will take some time for discussions. I will first introduce what my company does and how I progress within the company. And because we have partnered with ARUP, so I actually have pretty decent exposure to 2 different companies and made some observations. And then, as I said, I was really hesitating going into industry, and I had my own thoughts and doubts, and I want to just discuss some of my thoughts. And then what does success look like in an industrial setting? And in the end, there will be questions, because I'm pretty sure my doubts and thoughts are not everybody's, just my personal. And the company I'm in is obviously called IDbyDNA. And the name speaks for itself. We are both a local company and a Silicon Valley company. Currently, we have a lab and office space in Research Park. And we also have lots of people working in Silicon Valley because it's also a very software heavy company. What we do is we do massive parallel next generation sequencing on clinical samples to identify the pathogen that causes infection. And we chose approach to go from the sample itself to the biochemistry, molecular biology processing, and the sequencing and data analysis, and all the way to clinically actionable reports. So it's all encompassed service for infectious disease. And it has been very interesting for during the COVID as well. So this is the my experience with the company. I joined the company in 2015, and I was actually employee number 2 back then in the company. And I joined with a PhD from Drosophila genetics, like Kent mentioned. And my core competency back there was just molecular biology. And I learned the next generation sequencing on the job. And with a very, very small team, we have like 5 or 6 people in the company back then. And we developed and validated and launched a test with our partner ARUP in 2017. And in 2018, the company grew and I was promoted to senior scientist. And we developed and validated the test all over again and launched it in 2019. And right around the time we launched the test ourselves, I was given a task of being an interim clinical lab manager, trained and established and validated the process so that we could actually service. So we are actually doing this clinical test in Research Park in our own clinical lab. And so samples sometimes sent to ARUP and they will give to us to test. And 2020, I was promoted to associate director as laboratory technology. And we partnered with Illumina and we launched very exciting products in 2020. So that's it's a really short time. And between the years 2015 and 2019, we had very close collaboration with ARUP. So I'd like to just share some of my observations between those two companies, just contrast. So obviously we've been around for just a handful of years. ARUP is approaching its 40 years anniversary. And so because of that and the structure, we started with like less than 10 people and now we have less than 100 people. And ARUP employs thousands of people all around the country. And the style is quite different because for us, especially when we started, every single person is essentially a department. If something needs to be done and you're not doing it, it's never gonna happen, right? At ARUP, on the other hand, because it's very well organized, you would have a technologist and a technician, they would have very different roles. So that comes to different types of expectation in what you're going to do. And of course, the business models are different. ARUP is very stable and they expand their test menu pretty aggressively. And we are focusing on our core competency. We just do one test and we make it really well. And so those are what's on the surface. However, what's essential is invisible to the eye, and that is company culture. And company culture are essentially in all the employees' heart. And then culture is actually determined by why a company exists. So when a company actually figure out why they exist, what is the core to the company, and then that determines how they're going to address something, and then that determines what they're going to do. So that's a very interesting thing. And then by those different dimensions, all companies are essentially very different. And that means when somebody wants to go to industrial, of course, they need to choose carefully and look at which company they want to join by a holistic view. On the other hand, don't be afraid to make mistakes because, well, if you make mistakes for the first few months in a wrong company, where there's always another company that will fit you better and you are going to learn from your mistakes. So that comes to my earlier ideas about industry jobs that are probably not most accurate. And I want to talk about my thoughts on meritocracy and the stability for industrial jobs. So meritocracy, from my perspective, essentially is fairness. And this is a very laughable, simple model for merit. For instance, if you did really well on cancer genetic test, you are going to be rewarded with a high point. That's direct relationship to how well you did on the test and how you are going to be rewarded. This model is thrown out there to be torn apart, of course. Several things. First, merit is an intrinsic characteristic of an individual, yet reward is extrinsic. So reward is not directly related to merit. In a very fair and stable, mature society, reward should be related to the value somebody is offering to the society. And another thing that doesn't really match this is value and merit may or may not directly correlate, right? And I want to bring up another one that is actually a person's merit is not a linear thing. A person is, if you look at a person, that person would be a holistic individual and with their strengths and weaknesses. And all of us have different strengths and weaknesses. The amount of value you're going to bring to your community in a company setting depend on how your strengths and weaknesses fit into your department. And in a larger sense, depending on how your department fits your company. So this is all situational. But on the other hand, I would argue, if you expand your concept of merit from just academic accomplishment, how well you do on tests, to a whole set of, to begin with, emotional intelligence, communication skills, and all of the other strengths and weaknesses combination, potentially you can make the argument that an industrial setting is still meritocracy because it's just looking at merit from a much broader perspective. So that's my argument. And the second thing I was very kind of uneasy with is the stability. It actually happened to us because last year, we're a growing company, but still we had a round of layoff last year. And one of my very good friend got laid off, and she actually took a leap of faith to join our company. She had a job of like past 20 years at a lab at the U, and she was extremely comfortable there. She took a leap of faith into our company and unfortunately was laid off. So that is something that is really potentially very scary. I want to argue that this is a dynamic balance. We shouldn't just look at what the company is doing to each individual. At the same time, I think for each individual, we should also look at how our core competency or our development actually fit in the goal of the company. Of course, the goal of company is changing much quicker, but at the same time, as individuals, we can take control of what we're doing. Like we said, there are so many different companies. If one of them didn't fit us well, the other one definitely would. So we did have a round of layoff, and all our previous colleagues found a pretty good position, including my friend. And she now works in a lab in HCI, and she loves that lab very much. So that's another thing about stability is control. When we, a sense of control is essential for people's happiness and well-being. If stability is at risk, how do we actually gain the control of our life? My current consideration is first, we embrace the concept of change. Well, we're all biology. So we understand the very fact of metabolism. The hallmark of being alive is a dynamic balance. It's an equilibrium, it's never static. And then with that mindset, I think essential thing is to learn and expand, constantly challenging yourself, constantly looking and seeking new opportunities to learn. So that's what I have to offer. There is never really a true stability. It's kind of a psychological, almost illusion. That again. So come to the next point, what does success look like in an industrial setting? And the logic of success, coming back to the same, the existence of a company starts with why. So the logic of success naturally ties back to the why. So once the company, ideally a company aligns its activity and the strategical resource allocation and everything to their why. And the levels of the company, if it's large enough, it has a hierarchy, personal or team or department, and the company, all the goals should align to the why to make the company successful. So the point is, the success of an individual in a company is really not about the individual. It's about the team. We have a saying, we IDbyDNA, you succeed as a team and you fail as a team. So that's part of our culture. That's how we kind of sustained and survived so far. And again, in a company, don't be afraid to make mistakes, because that's especially for startup, we made so many mistakes. This is crazy. And the true point is we're always learning. We're learning as individual and we're learning as a team. So it's all about how fast you can make mistakes, how fast you can learn and iterate from your previous mistakes and do things better. We're never perfect. We're always going to make mistakes, but can you actually get the most out of your mistakes and allow them to support you and eventually be successful as a company? So that's my current understanding of how to be successful, just to make the company be successful. And the biology degree, what can the degree offer in an industrial setting? I want to just step back and talk about just in general how somebody look at the career. So this is a Japanese concept. I really like that because it looks at 4 different dimensions of 4 different aspects, let's say, what you're good at, what you like to do, and what the world actually needs, and what you can get paid for. So if you do not satisfy all 4 of them, some things will be missing a little. And of course, you are not going to find a perfect balance among all 4 of them. But again, that's a kind of a trade-off. So for everybody in biology degree, if you want to go to industry, I think you have a set of core skill for what you're good at, the green circle already. It doesn't matter which letters are after your names. you all come with knowledge and technical skills, and also critical thinking skills. It's just a matter of how broad or how deep they are. So we're all pretty good at a set of core competency. And if you don't want to, you don't have to go further in like going after more letters after your name. So that's the green part I'm fairly confident everybody's taking care of. And another one I think we really need to pay attention is what you love to do. And this is a kind of a very personal thing. I got lucky. I really, really like what I do. And it's kind of, for me, it's a challenge, and it's really kind of push me to learn and go out of my comfort zone. And that's what I like to do. And then what I want to say is, don't try to wait for something you like to do to jump on your laps. Take initiative and go out and try things. If you try something, there are two outcomes. Either you like it or you don't. Either way, you learn something, you either continue or you change direction. Like Steve Jobs said, just keep seeking, don't settle, look for that. So that takes care of the green of the yellow circle and what the work needs and what you get paid for. Well, if there's a job open, that means the company believes the work needs it, and the job open hopefully comes with salary and benefits, and that's how you get paid for. And this is put yourself on the hook. That's a story I heard recently from Six Golden, and he said it's like people in Turkey, when they go buy bread, if they had extra money, they buy two loaves of bread, and they took one and put the other one on the, tell the baker to put the other one on the hook. And when somebody else is hungry, they come to the baker and say, hey, is there anything on the hook? So I really like that story, to put yourself on the hook. I think it's more intense than just show up for life. It's actively offering yourself to the community, to the society, to make your contribution. And the fact that I decided to come and talk is because I see this as an opportunity to put myself on the hook. And this is my email. You can also find me on LinkedIn, and feel free to email me if you have more questions or you're curious about us or whatever, anything. So that's the end of my talk, and I hope we have time for questions.
Yeah, we have time for a few questions. So if anyone wants to unmute themselves, and also give a little hand emoji or clap if we see you.
I appreciate it. You guys are so nice.
I think I do want to ask something, because this is definitely one of my favorite presentations by far in this class. But I'm trying to ask for an advice, but to be honest, I don't even know how to phrase my question. But I know I want to ask you for advice. What's your advice on deciding on a career after biology? So I always know that I liked biology since high school. So I started college as biology pre-med. Then after the pandemic, I had some time to think, and then I switched to, I'm still biology, but I switched to pre-dental. So now I'm thinking of dental school. And I really like the model that you showed. And I don't know, I feel like I want your advice, but I don't know how to ask your question. So that's pretty embarrassing.
No, it's not. Well, I definitely have been there. It's like that is why I'm trying to kind of do stuff like that. My advice is kind of introspectively and see what really turns you on, like what really gives you energy, sort of. What things you enjoy doing, even if nobody's paying you, even if you're not having, nobody's testing you on anything. Mm-hmm. Does that make sense? So yeah, for me, my thing is reading. I can't stop reading. And that shows I'm pushing myself. I like to learn. So I like to challenge myself to find something that's kind of really excites me and give me opportunity to learn. So for pre-med, for medical and dental, if you really don't know, after the pandemic, maybe shadow somebody and see what their life is like, and see if what they do day to day is really what you want to do. Because some people are really driven by the passion to help people, and that's what got them into medicine. But then that's a kind of a very personal thing.
Yeah.
That makes sense? Email me if you want, or find me on LinkedIn.
Okay, thank you so much.
Lane, do you have a quick question? And then we need to turn it over to the next speaker. Sorry.
Yeah. So you mentioned that you were one of the first employees of this company, if I heard that right.
Yes. Yes.
How did you get in on the ground floor like that? How did you become the second employee or whatever it was?
The first employee was in the Bay Area, and I think I struck really lucky. I accidentally saw an email. They were looking for molecular biologists in the Salt Lake City area for a startup, and there was nothing. And I just felt like I was like almost compelled to call that number, and I called. And the CEO I asked the CEO, what's your business about? Oh, we're doing a diagnostic. I said, well, we have ARUP here. How can you survive? He said, oh, they're our partners. I said, fine. So that's it. And later the employee number one told me, like right before that happened over a weekend, they had an offer ready for somebody else right after the weekend already. If I didn't make the phone call, that position wouldn't be mine. So I that's all I can say. That's the story of how I ended up there.
Cool, thank you.
Yeah, it's really
Excellent.
great.
Okay, thank you. Sorry, John, a ton of time. I know 50 minutes is not enough time. I know there's a lot of questions, but if you can stick around, I'm sure there's questions after. I'll hand it over right now to Gary Rose.
Yeah, hi everyone. And that was really a nice talk and very thoughtful. Really enjoyed that. And I particularly enjoyed your quote of the ancient Greek and Heraclitus. And there's another good one too from him, and that is that I think is relevant to the class here. Much learning does not teach understanding. Think about that one. So what else was I going to say about the relative to what you said? Oh yeah. I think that you really hit the nail on the head, really brought up a very important point when you said that if you do something that you like, if you do something that's really compelling to you, that you're probably going to be okay in the long run, right? And that's great. So I have the pleasure to, and I'm very proud to introduce Todd Alder, Dr. Todd Alder, and who was a student in my lab, PhD student in my lab. And I can't believe that was about 20 years ago, but I think it was, right, Todd? About that. Did we lose Todd?
Yeah.
Oh, here you go. Hey, Todd.
Hey. Yeah, it was, 20 years ago.
20 years ago. Hard to believe. So Todd is really, I think, one of the, when we talk about breadth, one of the broadest individuals that, in terms of his his interests, his expertise, I mean, ranges from engineering to, of course, biology. You got a biology degree from the U, but then also tackled a very challenging neurobiology topic for his thesis, for his PhD thesis. His work was foundational. It really laid the foundation for our current work, and that continues 20 years. You know, it's still we're still going strong on this, and Todd's thesis really laid the foundation for this neurophysiological analysis of the annular and auditory system, and he was the first to discover what we call the interval counting neurons. And that was a very exciting time. I think back on it, and that was one of those things you just couldn't wait to get up the next morning to think more about it, and it was just a fantastic time, and it launched a process whereby we've continued to explore that, and now I can't go anywhere in the neurobiological world that someone doesn't say, "Oh, interval counting neurons, Todd Alder." Yeah. So, that's another thing that's great about it too. Well, after finishing his PhD, Todd went on to law school and used his wealth of experience and knowledge towards patent law, while of course being able to make use of his experience across the spectrum, that spectrum that I talked about, and he not only did he do that, but he also kind of started a movement going, I guess you'd say, because I've had 3 PhD students that have gone on to law school, and I still haven't quite analyzed all that and processed it, but I think Todd's going to shed some light on it, hopefully here. So it's been a great ride, Todd, and I don't know if there's anything else that needs to be said to introduce you, but I won't occupy any more of your time, and I'm looking forward to hearing what you have to say.
Well, thank you, Gary. I'm humbled by your words. First, I was going to say it's good to see Gary here, because I've been waiting for him to go to law school and get a decent career. But I don't think that's going to happen.
No. When we go back to that last slide that was shown, I guess I'm one that didn't really ever hit the center of that, did I?
And it's funny when he mentions the interval counting neuron. I think the fear that we had was it would never find another one. That it was some kind of one-off, and
yeah.
that was what scared me. So just real quickly, the interesting thing about that was you don't often hold neurons for a long time, and I think I had that one for 2 hours or so, and I'd written a computer program to make fraud calls, and it didn't do what I needed to do to test it. So I shut the system down and held my breath and crossed my fingers and wrote some code, recompiled it, brought it back up, crossed my fingers, turned the auditory back on, and the neuron was still there. And I was able to then delete pulses, and that's how we came up with it. But I give as much credit to the frog as I do anybody else for hanging in there. So it was an exciting discovery. Let's see. I need to share my screen, which is. Do I share it or do you share it?
You should be able to at the bottom of your screen.
Let's see. I got.
It's that green button, share screen.
Yeah.
At least on mine it is.
We're using something different where I am, and
Oh,
I'm not happy with them. There we go. Can you see that?
yeah, that
Yes.
looks great.
It's here somewhere. That one? That one. There we go. I guess I should explain how I left, and maybe Gary will finally understand what happened. It's basically, when you have a family and the amount that they're willing to pay a postdoc back then, I was kicked. I was drugged, screaming and yelling from academics because it was something that I really loved. But the finances just weren't there. So, for any of you that are, in the student loan territory, realize that they don't defer your loans when you're a postdoc, and be careful, prepare for that, because that can sneak up and bite you. I went to law school, which was a very easy experience. I mean, when you've been through chemistry, physics, and biochem and everything else, it's reading about John Locke is really not all that difficult, and you're with a bunch of history and communication majors that are terrified. Anyway, I just wanted to briefly kind of go over what it's like to be a patent attorney, and kind of how you can get there without having your sanity torn from you, because you are working with lawyers, and that can be an interesting experience. So the areas of intellectual property that there are patents, trademarks, and copyrights. And I just wanted to list, I do mainly patents, I do some trademarks. But if you compare the three areas, patent work is really extensive. The preparation of the patent applications, the prosecution, which is the fight with the patent office to get something allowed, and then it's very extensive litigation. Trademarks are a little easier, and copyrights are really trivial. But all of the litigation is extensive. I've stayed away from litigation. Not something that I really want to hang out doing much. I want to throw this up there. This is the very first patent that was ever issued. It was for potash, process for potash. And can you see the who signed it down there in the lower?
Was it
right.
George Washington?
Yeah, George Washington. So the president used to sign all of the patents, and this is known as the X001 because they started over with number 0 after this. But it was it's always fun to look at this, just because when you think of how long this patent system has been in our country, it was part of the Constitution, and along with copyrights, and it's an important part of building businesses. It's also an important part of businesses like Apple and Samsung beating the hell out of each other. It was kind of fun to watch. So here's actually something, I don't know how many of you are familiar with. I guess I should explain something first. I did a lot of biotech and chemistry work, and I still do. I had an opportunity about 5 years ago to represent Intel. And so I took about 9 months and gave myself what I'd probably consider a master's degree in memory architecture, and started working for them. And a large part of this is, Gary mentioned I have a really broad background. It's really a broad interest. I love, all areas of science. And he's responsible for a lot of that. He's the one that brought in concepts of sexual selection and evolution into, animal behavior into my dissertation and the things that I was thinking of. This is just to show you some examples of technology that I've worked on. I don't know how many of you've heard of 3D cross-point memory. It's a new memory. It's probably the most unique, fundamentally different computer memory technology that's arisen since the 80s. And there's no transistors in it. You see the selector over here in this memory cell. Really, they line up a word line and a bit line, and they heat it up. And depending on how fast they cool it, it's either crystallized or amorphous. And then they can detect the crystallized, whether it's crystallized or amorphous, from the voltage they put through it. So unlike other memory, you can look at a single memory cell at a time. It's non-volatile, so you push that button for 10 seconds and shut your computer down, and everything stays in memory. So and there's some really fascinating technology coming out of that. Here's just one of the dumpstick memory cards with they call it octane memory. I probably did about 16 patents on this, which was a real kick. It was fun to see it come out. Let's see. Oh, we don't want to go there yet. Nobody look. Oh, nobody look. Okay, I wanted to go show you a couple of patents just so you can see kind of what these are like. These are actually a couple from Intel that I did. I've also done, like work for ARUP, a lot of just to let you know the variation of what you can work, what you can do in this field. For example, biomarkers that have autoantibodies bound are very difficult to detect because you can detect the non-bound biomarkers, but you really have a difficulty detecting often those that are bound by autoantibodies. So I've done a lot of work in those areas of separating the autoantibody bound and processing them so that all of the for example, thyroid globulin. You can't test thyroid globulin directly until recently because you can strip off the autoantibody bound antibodies. This is really an interesting one just because it has nothing to do with memory technology. It actually has to do with data storage based on DNA sequences, which is something that's, if you look at the rate at which we are storing data, we will be out of silicon in 2040. I mean, there will not, we will bypass the supply, we will outstrip the supply. And so there are a lot of companies trying to find technologies that they can store data that's not in a silicon form. And this is one that is just a massive compression of DNA down into a fragment that is highly compressed and can be regenerated back to its original state. That's just some background. But it's not really important what's in here. I just wanted you to see, a typical patent has drawings in it. I do my own drawings. I used to be a draftsman, so I don't have to send things out, which is nice. So I don't have to wait for them to come back. But you have a series of drawings that are required by the patent office that if you need some figure to explain what it is beyond the text, you need to put it in. Most of us put in a lot more figures than we need because it's a picture's worth 1,000 words, right? So anyway, this is just and I will put this with the slide deck if anyone's interested to look through that. Then we just have to have some computer resources to be able to implement it. And then the biology GUI stuff that has to go interface with the computer. So every patent also has a written section. The background's pretty much worthless. Examiners hang you based on that. So mine are very short. Description of the drawings, and then we have this description of the embodiments. So when an inventor comes to you, they give you, oh heavens, sometimes 2 lines of their idea. And you have to generate a document that legally encompasses that idea. And you also have to often expand that idea into something that's worthwhile. Let's say that someone comes to you with, like, hey, let's call it a widget that they want to invent or they want to patent. The way you look at that is you try to encapsulate that in a legal claim. It's like putting down stakes or boundaries around what you believe their IP to be. One thing that I do is then I turn myself into someone who wants to get around that product, and I tear it apart. And I say, well, I could get in here, I could sneak in here, I could make a product that's out here without infringing those claims. And I'll explain a little bit about claims here in just a second. But if you play the role of that infringer, you expand the scope of your claims in your application, and it becomes a lot more valuable. And a lot of what's in this specification are details that end up making that idea more valuable. We have some sequences in here which have to be sent to the patent office separately. Interestingly enough, the first genetic sequences, the big ones that were sent to the patent office, was before they allowed electronic sequences. They were delivered in Ryder trucks, and some of the applications were over 100,000 pages long. I'm not quite sure what an examiner would do with that, but so here are the claims, and they're often difficult to read because they're written. Patent attorneys have minds that I guess are not normal, but we write them in a certain way that captures that what the inventor believes their idea is. That's expanded to capture infringers that may come in and try to build a device that's just right outside of your claims. And so to infringe this claim, another product would have to have every one of these elements in it. And if you've made a mistake and you've made it a little too narrow, and there's a little spot where an infringer can get in and build a similar device that doesn't have all, that is missing one of those elements, then they're going to be okay working in that area. One of the most stressful things I think about being a patent attorney is when you write this application, you file electronically, and you sit there with your finger on your mouse, because once you click it, it's stuck for 20 years, and there's no way to change it. It is quite stressful. Here's another one, and same from Intel, that just to show you something interesting. This is growing DNA on a CMOS chip. CMOS chips are the chips that are in your camera, the imagers. And there's systems to be able to put just microliters of solutions onto these really small pixels and to grow sequences of DNA in them. This is just showing the machine that picks up, depending on what you're sequencing, the sequence you're growing on this side, it will pick up the proper base from this solution and deposit it in the proper pool over here. so that it grows the next, adds the next base. Then it moves everything out. It sucks the solutions out and then brings in the next batch of solutions. So it's really interesting sometimes to put biology into these electronic devices, which I've really enjoyed. Here's one where there's 5 pixels in a single, one of the single cells of the CMOS. You grow different DNA chains off of each of these, and then there's a process of actually hooking each one together to expand the chain, finally out into a looped structure that then they can cleave and use. It's an interesting idea. So patents go from things like this that are interesting and fun, and then they go to things that are what I'd probably describe as a nightmare. It was a challenge. Needless to say, it is pretty much nothing but chemistry. Again, I'll leave it for you for your viewing pleasure. The text is just nothing but R groups and variations of R groups. I hope that's not scrolling too fast, but I've got to move to something else. But as you get down here to the claims, again, the claims are even worse than the ones I showed you because they're basically just claiming a structure with about every substitution you can think of. So, yeah, that is, those are the ones that you really have nightmares about. Let's see, where was I?
Todd, we're actually nearing the end of our class.
Okay. Let me
So I don't know if you
just,
had final other.
yeah, let me just do this really quickly. We've got, this is the prosecution. That's all that's involved in prosecution. So when you put a patent through the patent office, that is actually what you have to go through. Just to show the complexity. That's the international system. Again, I'll leave these slides for you. There's some, what you do on a daily basis. That's the docket over time. It's like a fire hose in the face because the more applications you put into that system, the more they come up and slam into you. At times I've had 500 cases in that system at a time. When you become a partner, you can spray the water on someone else, which is nice. And there's a couple things in here if anyone's interested on how to become a patent attorney. Got to have a hard science. You got to go to or get a lot of physics. You got to take the LSAT, go to law school, have a nasty FBI background check, graduate and pass the patent bar, and then you become an attorney. If you have any questions, there's my contact information, and feel free to call me or actually I'll put my cell phone in there. You won't get me at work. I'm living out, like the rest of us at home. So thanks for your attention, and that's it for me.
Thank you so much. See, do hand emoji clapping. We see y'all. And if anyone has any questions, you're welcome to unmute yourself and ask.
See, in a class, everyone wants to go home, but they're already home.
It's true. We're already home. The best part about it.
There was that slide you were showing us of a patent, and it was like a memory storage device that you said you were putting DNA on. Is DNA acting as like a sort of like random access memory
It's on the
system?
It's purely storage. So yeah, I mean, I got rid of it. I'll put it with a slide deck, but it's purely storage for long-term archive. There are folks working on being able to use real-time DNA, but the problem is the sequences are not fast enough. And what they're really doing is using huge banks to try to speed that up so that they can use it like RAM. I don't think it's going to happen. It's just too difficult. But when we get to the point when we're out of silicon, that ends up being the problem. Things that build memory, gallium, comes from China, and there are a few mines, and when that runs out, we have no more cell phones and we have no more computers. So, that is a stress. So this is actually a nice little system that puts a single cell in each bubble and then tracks genes in that, so that from an individual cell, because it's all barcode. So you can, do whatever experimental work you want to do at a single cell level. PCR up everything together, and then separate it back out based on its barcode. It's really kind of a cool technology.
I have a question.
Mhm.
I've heard that to be a successful patent attorney and to be competitive with a biology degree, you really need to have an advanced degree as well as go to law school. In your experience, is that true, or could you just go straight from undergrad to law school and still be fine?
I think you're fine going from undergrad to law school. I think it makes it a little easier to have a PhD because you're a little more attractive and partners use you to attract clients. But I'm the only PhD at my firm. We've had probably 10, just people that had a BS in biology over the years. To me, it's really how well you think and how well you write. Part of the trouble with, so I write probably 100 pages, 200 pages a week of material. When I'm really doing patents, it's a lot worse than that. When I'm hardcore doing patents, patents are 50 pages long on average, maybe, and I sometimes do 2 every week plus office action. So if you don't like writing, this is not the career for you. But yeah, I don't see any problem with you having just, I don't mean to say just, but with not having an advanced degree. If you can think and if you can write and if you can take criticism to help you learn, then I would hire you, immediately. So.
Hey, Todd, I've got a question.
Uh-huh.
So you're a partner at the firm that you're working at now. So do you supervise a team of lawyers who help you with, assembling these patents and prosecuting them?
I did, but I don't at the moment. A lot of it's because COVID has turned, a lot of the industry down a little bit. People have pulled back from, manufacturing. I'm getting a lot more work now. And so I'm probably going to have, at least 1 or 2 associate attorneys that I'll work with. And basically in that, I'll have them, I work with them to draft the application. They'll do claims, we'll discuss them. I'll tear them apart and they'll cry a little bit because they have to redo them. But patent law, the learning curve for patent law is 10 or 12 years. It's difficult, but it's challenging. Even though it's challenging, it's a lot of it's. I mean, you don't have to see people getting a divorce or custody of children or having these. There's some attorneys that they have just sad people coming in, and inventors are always excited. There's no ugly babies, So, but yeah, you know, I'll have some attorneys working with me shortly. So.
Are there any more questions for Todd?
So Todd, how much did writing a PhD thesis help you in terms of preparing for the amount of writing that you needed to? Was that?
That's an awesome question, actually. You know, I was known as one of the best, you know, best patent writers in my firm, and it hurt some of the other associates that came in at the same time I did because I wrote so well that everyone wanted to work with me, and the others were almost blackballed. And I felt really bad about it, but you know, I tried to tell the partners I've been writing for years. You know, we did, you know, 6 or so papers together, 5 or so papers together, and a book chapter. And I just, you know, they come right off of, you know, a BS. You know, one of them had a BS in chemical engineering, and I'm not sure how much they write. And he was kind of blackballed. I felt bad about it because I wrote better than he did. You know, I had better. I write better than I speak. But anyway, yeah, it's important, you know, that's something, work on your writing skills, because it is nothing but writing. I mean, if you think about, I mean, how long is you know, an R01, you know, how many pages do you have in that? And you think, I have to do that in about 25 hours, you know, a patent application that's 40 or 50 pages long, plus all the drawings. That's about the time I give myself is 25 hours. So.
Yeah, towards that, my memory was just jogged, and I remember Todd going at the time when he was writing his PhD thesis. I remember a period of absolute terror at the prospect of dealing with the thesis secretary.
No, thesis Nazi, I think was the word everyone used.
and I remember with much trepidation associated with this event, and I still remember like it was yesterday, Todd coming into the lab one morning. I hope I remember this. Correct me if I don't remember this correctly, but he had this sort of bewildered look on his face, and he said, "You know, I just talked to the thesis secretary, and the thesis secretary said that she rarely ever sees a thesis like this that was so flawlessly written." Something to the effect that she wondered whether most theses ever actually get read. You know, they were so bad, so poorly written. But yeah, that fear was unfounded, apparently, in that case. You remember that?
Yeah, just real quick, it was her ruler that got me. So when you print out, for some reason, Word is not consistent with its margins, and she checked every single margin on every single page, and some of them were the wrong, you know, with the wrong dimension, but it was just Word. So I was sitting there shifting the, you know, the trying to get the right, and I swear her ruler, it changed. It was terrible. That was what the fight was for me, was the ruler. So, but yeah, she loved my thesis.
Well, your drafting experience helped there, right? Oh boy.
All right. We are over time, so anyone 2870, you don't have to stay, but you're welcome to stay as long as Todd is happy to stay answering questions.
I'm just stuck at home.
Like the rest. Are there any other questions?
So I have a question. How do I get you the slide deck?